Hey everyone, welcome to this second lecture on coordinate geometry. In this lecture we'll be going through straight lines. First of all, we'll go through the different forms of equations of a straight line, in which basically I'll show you the different equations that you'll be seeing that would represent a straight line. Of course, a straight line is never represented in the same way, because there are different forms to represent a straight line. I will be going through almost all of those forms. Then we'll be going through the gradient of a straight line, the slope and its properties, and then finally the intercepts. Because if you know the slopes, if you know the points on a line and the slope and the intercepts, then you can make your own equation for a straight line. So first of all, let's define the straight line. What is a straight line? Any line cannot be called a straight line in math. A straight line is any line that does not change direction. So if there's this line that goes from one point to another point and it keeps going in that direction, that line will be called a straight line. Other than that, no line, no matter how straight it looks like, if there's a line going in one direction, if it changes direction, whether upwards or downwards to any other direction, that even no matter how straight both of those lines are, we're not going to count it as a straight line. They would have separate equations but not the same one. And the slope of the line is basically the gradient of the line. It is the measure of the change of the vertical over the horizontal, that is the change in the vertical direction over the horizontal direction. Now this could be negative or this could be positive. We'll see how different lines look like in positive and negative, with positive and negative slopes. If it goes from a lower point to a higher point, then it will have a positive slope, and vice versa. It could also have no slope at all. If it is horizontal lines don't have a slope. So we'll go through that, don't worry about it. I'll show you the lines as well. Then in the end we'll touch upon the x-intercept and the y-intercept, which are pretty self-explanatory, that the x-intercept is where the line cuts the x-axis and y-intercept is where the line cuts the y-axis. So these over here on the slide, you can see different forms of equation of a line. The first form is the general form. So in a general form, you have this ax plus by plus c. Now in this is pretty straightforward. You know what an x and y is, and you'll have different constants over here like a and b. We can convert it into a standard form as well, that is just take the c on the other side and we have a standard form. This is the most famous part of a straight line. This is the most famous form of a straight line, that is the point slope form, because it has m over here. M basically is the gradient, and these are the points over here, y minus y1, x minus x1. If you look at this closely, if you take this x minus x1, all of this over here, y minus y1, it will become y minus y1 over x minus x1. That is the definition of M. That is the definition of a gradient. So this is the pretty standard definition of gradient over here. We just like moving the horizontal change x minus x1 on this side, and pretty much and everything else is the same. I would like to correct myself on one point. This is actually the most famous equation that you will see representing a straight line. Y is equal to mx plus b. Y and x over here are the different points on a line. M is the gradient of the line, and b over here represents the y-intercept. You'll see how as we go forward, how this is pretty easy for you to remember, and why this is the best way to represent the equation of a line. You don't have to remember the name, slope, intercept. It's pretty straightforward. You have a slope over here m, and you have the intercept y-intercept b. Then there of course like pretty intercept form and 2-point form. You don't have to remember these because these are not pretty common in math. The most common one is this one, y is equal to mx plus b, and as I told you, y and x are points on the line. Minus 1 by 2 is the gradient of the line, and yes, gradient can be negative as well, and minus 2 over here will represent the y-intercept. So let's do a little recap and let's see what a gradient is. So a gradient basically is the change in y, that is the vertical change, or the change in x, that is the horizontal change. It is also called the slope because it looks like a slope. If you look at a slope, you'll see that as you go up the slope or down the slope, your y and the x-axis are changing, because y-axis represents the rise and the x-axis represents the run. That is how we have slopes in the real life as well. So you can relate this to your real life experience as well, so that is much more easier for you to remember. In terms of math, this is the way to calculate the gradient. that is the y2 minus y1 over x2 minus x1, which basically means is that the change in y, that which is that first y was 1 on this equation, then it went on this point, and then it went to this point y2. So there was a change in the vertical points. Just like that, there's a change in the horizontal points x1 minus x2. Once you're done with that, you will have the gradient of the line. So let's look at a few examples over here. So this is a pretty standard gradient. You see over here, you have this point over here, and the line goes, the straight line goes up till here. So if you look at the change in the vertical side, this is 1, 2, 3, 4, and change on the horizontal is 1 and 2. So the pretty straightforward answer to this is 2. So the change in y over the change in x. This will give you a positive gradient because the rise is positive, because you can also see it over here, this 4 divided by 2, it will be 2, and it's positive 4 and positive 2. On the other hand, if you look over here, it is from a lower point going to a higher point. Now moving on, now over here, this is the second type of gradient. In the second type of gradient, what happens is over here the change n is the same, but the direction is different. If you look at the horizontal change over here, it will show 1, 2, 3, 4. On the other hand, the vertical change will show 4, and the horizontal change will once again show 2. Now the difference between the previous diagram and this diagram is that the change over here is in the negative direction. That is, the point we're coming from a higher point to a lower point. We're going from a higher point to a lower point. That's why it has a negative 4 in terms of the y change, because this goes in the negative direction. It goes in the negative y direction. That is why we have a negative slope for this. We have a negative gradient. Moving on. So we have over here this line, which you don't have to confuse. It's not that confusing. So this is a horizontal line. Just solve this in the way that we solved in the previous slides. Look at the horizontal change. What is the horizontal change? Horizontal change is 5. So that goes over here. What is the vertical change? There is no vertical change over here. The vertical change is 0, because the line starts over here, it doesn't go up, it doesn't go down, it goes in the same direction. So this is a straight line because it goes in the same direction, and its vertical change is 0. It does not change y, it only changes x. So we have 0 by 5, and that will give a gradient of 0. So remember this rule, that the horizontal lines will always have 0, and this is the proof for that. I will always have a gradient of 0, and this is a proof for that. Now what about the vertical lines? Now you see the vertical lines are a bit tricky. Why? Because you see, if you see the horizontal change, there is no horizontal change, because you see they don't have a horizontal part over here. But there is vertical change. The vertical change over here is 3. Now anything that is divided by, if 0 is divided by anything, the answer would be 0. But if anything else is divided by 0, the answer would be infinity. Over here we'll call it undefined. So if you have, just remember this, you go through your classes in your engineering and in your advanced math and physics classes, you will see that anything that is divided by 0 will give you an answer of undefined. That is, they give you an answer of infinity. Now moving on, let's find the answer to these questions. What is the gradient of this line? Well, you can look at the graph over here, and you can make out what the gradient is. Just by looking at the graph. If you look at the graph, you select 2 points, like just say we've selected these points over here, and we see that if we go in this direction, we have a run of 4. That is the horizontal change of 4. 1, 2, 3, and 4. And from this direction, from this point, we select what the rise is, what the vertical change is, and the vertical change over here, if we calculate this, would be 7. So you see, this would be 7 by 4, and since it goes in the positive direction, this will be a positive gradient of 7 by 4. Let's look at another example. Now in this line, if this is confusing to you, rise and the run, so just look at the graphs over here, and you can see from the y axis that what the answer is. If you look at the y axis over here, you see this point, or just like 2 points on this line, and you calculate from the origin, you can see that it moves in the vertical direction of 2, negative 2, that is downward, and horizontal direction of 4. So the gradient is going to be 1 by negative 2 by 4, which would basically mean 1 by 2 if you simplify it. Moving on, then this is the most common way of finding the answer, and this is how I would like you to find the answer to any gradient question. You will have a graph, of course, and just find out. The first thing that you need to do is that you need to find out 2 points on the line. Once you have 2 points on the line, one point will be x1 and y1, the other will be the x2 and y2. Then you use this formula over here that we discussed when I was talking about the different forms of a straight line. Use this formula over here, plug in the values, and you will have the answer. This is the most easiest way of finding the answer. This is the most easiest way of finding the gradient, and there's less chance of making an error, there's less chance of getting it wrong. So I would like you to do this, that whenever you see a straight line, first of all determine if the line is straight. If you have determined that the line is straight, then the second thing that you need to do is find out 2 points on the line. Once you are done with that, the next thing you need to do is plug in the values to the formula. So straight line, find out points and plug in the values, and you would have the gradient. So just let's go through a pretty straight examples. So this graph just shows m is equal to 1 by 4. Of course you can calculate this. I would like you to look at this screen over here. I would like you to look at the slide over here, and you see the graph over here, and try to find out if this is the answer or not. This is basically an exercise question. This is the answer to the question 1 by 4, but you need to find out 2 points and try to get this answer. If you are able to get this answer, that means you're on the right track. Just like that, if you just take a look for it and take a look on it for like 5 seconds or so, and just take a look at this graph as well. The answer to this is negative 7 by 2. Please try to develop some intuition with regards to straight line, because you see this is a straight line that goes in the positive direction. So one thing is certain, that it's going to have a positive gradient. Just like that, over here this straight line goes in the negative direction downwards. So this one thing is certain, that you're going to have a negative gradient. Moving on, this once again goes through in the positive direction, so this is going to have a positive gradient. So the answer is 6. Try to solve this question, try to find out 2 points. We know this is a straight line. Find 2 points, maybe use the points that are colored as pink balls over here. Use this to find the answer to this question, that is the gradient of this line, and the answer should be 6. Over here, try to find the answer to this line as well. We know that this is going in the negative direction, so the answer is going to be -1, and negative gradient. This is going to be a negative gradient. Find out the gradient using these points or whichever points. Now moving on, let's talk about the x-intercept. So it's pretty straightforward. X-intercept is basically where the straight line cuts the x-axis. It could be anywhere on the x-axis. Even an origin has x point, even an origin is an x-axis. So this line over here, as you see in the slide over here, this passes through x is equals to 0 on the origin. So this intercept is actually on the origin, this x-intercept. So we'll say the x-intercept over here is 0. What about this one? What about this line over here? What do we need to determine the x-intercept of a line? We need to determine where it cuts the straight line, where it cuts the x-axis. But if you look over here, you would see that this line does not cut the x-axis anywhere, so it will have no x-intercept. Moving on, what are the x-intercept over here? Of course, don't get confused by the point that it is passing through the origin. The origin also has an x value, so the straight line over here is passing through the x-axis, and that's why at the point x is equals to 0. So that's why the x-intercept is going to be x is equals to 0. Over here, if you calculate, you look at the graph, you're going to see 1, 2, 3, 4, 5. The x-intercept is -5 over here. So remember the sign, people. Over here, the x-intercept is +5 because the straight line cuts the x-axis and x is equals to 5. Now let's look at the y-intercept. So y-intercept is the same as the x-intercept. All you have to do is, just look where the straight line cuts the y-axis. So that would be your y-intercept. Over here in this image over here, you can see that a straight line cuts the y-axis at y is equals to 1. So this would be the answer to this. Over here, the y-intercept cuts the y-axis, the straight line cuts the y-axis at y is equals to -2. Remember the sign, and you will have the y-intercept over here. So that's pretty straightforward. Just like that, in the x-axis, in the x-intercept we saw a straight line that went through the origin. and we said that the x-intercept is equal to 0. Over here the straight line goes through the origin once again, and we say that the y-intercept is y is equal to 0. Over here there is no y-intercept, just like that, because you see the straight line has to cut the y-axis someplace. Over here the straight line does not cut the y-intercept at any position, at any point, so that's why the y-intercept is going to be 0, because and we're going to write it as none. There is no y-intercept. And then in the end we have over here y-intercept of -3. This is pretty straightforward. Don't mess this up, it's really easy. So this is pretty much it for this lecture, and hopefully I'll see you soon in the next one, and hopefully you guys would be watching that as well, and we'll be continuing with more coordinate geometry. Thank you very much.